In organic chemistry, we have seen that although we write carbon-carbon bonds like this to represent different structures, they actually don't exist as straight lines like this. They are like this usually. Carbon, that's because there is 4 atoms around every carbon, right? So that brings in stereochemical effects. Just like this, even in our proteins or peptides for that matter, there is an NH3 carbon, H, C double bond O, NH, C, H. There's an R group here, R group here, C double bond O, O minus. All these atoms do not exist in straight lines like this. They exist in zigzag fashion. Okay, now these are just the carbons that I am showing on this line structure. Now if you go a little bit deeper into this, say this is the main peptide chain. Okay, some of these are carbons and some of these are the peptide bonds. Okay, right? Now there are a lot of side chains here. So let's say for example there is a side chain CH2, C double bond O, OH, right? Let's say there is another side chain here which would be just OH. What's the possibility here? These structures are close to each other. They are within intermolecular interaction distances. So as a result, what happens? As a result, there could be hydrogen bond formation between hydrogen and highly electronegative elements. And because of this, there is a possibility of these two units coming close to each other. As a result, this main primary structure that looks like this will not stay straight like this, but it will start twisting into alpha helices, okay, or the singular, this is a plural, alpha helix is a singular. It also forms bearer sheets. So again, what's a bearer sheet? So if you have a structure that looks like this is a protein structure, right? Peptide structure. So some of these are carbons, some of these are nitrogen. So this is the primary structure, right? Let's say there is another structure similar to this, right? So there could be a hydrogen bond formation here. There could be a hydrogen bond formation here. Okay, and so as a result, you see that there is a sheet formation like this because these are strong interactions, right? So this is known as a bearer sheet. And when you are specifying this structure or this part of the structure, what you're doing is you're not only specifying that it's an alpha helix or a bearer sheet, but you're also specifying the primary. So this level of structures is known as secondary structure. Secondary structure of the protein. So there are multiple levels of the structures of the protein, and secondary structure is the second level. So the first one is the amino acid sequence, which is the primary structure. The second level is the secondary structure, which is alpha helices and beta sheets. Okay, now the alpha helices and beta sheets contribute to the structure of protein. For example, collagen. This is a protein. This is found in ligaments, connective tissue, blood vessels, etc. This is a strong strong protein. This is a strong structure because several alpha helices are woven together. Okay, several alpha helices are woven together like a braid. Okay, so alpha helices and beta sheets, as in the secondary structure of the protein, contributes to the structural aspects of the protein.